Hey everyone, welcome to 7.3 Trig Integrals. This section is all about just what procedures to do in case you are left with integrals with trig. So if you ever asked, why would I have sine and cosine? That doesn't seem to be on my my list in the front cover of what to do. So what we're going to do is if they're in kind of this form, sine m, cosine n, right? So m and n are just some powers. You're going to try to get to a form to use the power rule. So what we're going to try and do is use the power rule to our advantage, right? So I can say, well, I've got sine to the fifth cosine x dx. So if I let u equal sine x, I know that du is going to equal cosine x dx, right? So right here is going to be my du, and then I'm just going to have the integral of u to the fifth du. So that's going to be 1 over 6 u to the sixth plus c, and then I can say that is 1/6 sine to the sixth x plus c. Whoa, there we go. All right, so that's really what we're trying to do. Okay, so here are some helpful identities from trig. First of all, you should know sine squared plus cosine squared equals 1. The other helpful identities are the half angle formulas for sine squared and cosine squared. So sine squared x, you can also write it as 1 minus cosine 2x over 2, and cosine squared x equals 1 plus 2x. I'm sorry, 1 plus cosine 2x over 2. And also see page 490 for some guidelines about what to do. All right, so I'm going to assume that you're going to go and look at those, and then we're going to move right on here to this next example. So it says evaluate sine cubed cosine to the fourth. So what we're going to do first is, I don't like this cube. All right, if I had a sine squared, I could probably rewrite it as a cosine squared. 1 minus cosine squared. So what I'm going to do is I'm going to break this up into a sine squared x and a sine x. Alright, so now what I would have is I've got sine squared x cosine to the fourth x. Let's just put those x's in there so they're right. Okay, and I've got sine x dx. Alright, so now I know that if I have cosine x equals u, then I know du is going to equal negative sine x, right? Right. So I know that this and dx. I know that this part is almost going to be my du. I just need to write my u as cosine x. So I've got the sine squared. So I want to be able to rewrite some of this stuff in terms of all cosine. So I'm going to rewrite the sine squared as 1 minus cosine squared x. So I've got the integral of 1 minus cosine squared x cosine to the fourth x, and I've got sine x dx. Remember, I'm trying to keep that because that's going to be my du. Alright, so then I'm just going to distribute this 1 minus cosine squared. So I'm going to get cosine to the fourth x minus cosine to the sixth x, right? Because I did this one, and I'm doing this one. Cosine squared times cosine to the fourth is cosine to the sixth. And we take all that sine x dx. Alright, so now let's just say u equals cosine x. And then du equals negative sine x. That means I have to make this a positive to change that one to a negative. So that means I'm going to put this negative out in front. And then I've got u to the fourth minus u to the sixth. And then du. Alright, so now I can rewrite that one pretty easily as 1/5 u to the fifth minus 1/7 u to the seventh plus c. And then we just have to rewrite this as 1/5 cosine x to the fifth minus 1/7 cosine to the seventh x plus c. And there is our answer. Alright, so there you go. Let's do this last example here real quick. I got to get a different marker here because that one's kind of running out of ink. So we have the integral goes from pi over 6 to pi over 3 cosine cubed over sine x. Alright, so I see a sine, I see a cosine. I probably want to get something in the other form. So if I look at cosine cubed, I think, well, I can break that cosine cubed up into a cosine squared and a cosine. So I'm going to do that right now. So let's just go, the integral goes from pi over 6 to pi over 3. I've got cosine squared x, cosine x, all over the square root of sine x dx. Alright, so now I think cosine squared, I can rewrite that as 1 minus sine squared. So then let's just, I'm going to write it over here, make sure I save some room here. So I've got pi over 6, pi over 3, 1 minus sine squared x. over square root of sine x cosine x dx. So I'm kind of thinking that's going to be my du right there, right? That's going to be my du right here, because I'm hoping that sine is going to be, I have everything in terms of sine, so that seems to make sense, right? Set my u equal to sine, that's going to be my du. Okay, good. So now I'm going to just kind of distribute this whole thing. So I'm going to say that's the same as the integral from pi over 6 to pi over 3 of sine to the negative 1/2 x, right? Negative 1/2, right? Because it's going to be this part, minus, and then sine squared minus sine to the 1/2 is 2 minus 1/2 is, yes, that's right, 1/2, right? So sine to the 3/2 x, put that in parentheses, and then we've got cosine x dx. All right, so now we can probably say u equals sine x, and we're going to say du equals cosine x dx, which we take care of all that. So now we've got the integral. I'm going to write it over here. The integral, I don't need to be that big, but I have it as that large, so that's okay. Pi over 6, pi over 3. So I've got u to the negative 1/2 minus u to the 3/2 du. Right, so if we take the integral and do all of that, you should be able to get your answer. This is now becoming an easy problem, right? So if I do all that, I should get the negative 1/2. So if I want to get this to be plus 1, I should have it to be the 1/2, right? So I should have it u to the 1/2. And what do I have to multiply that by to get to be a 1? I should have it multiplied by a 2. So it should be 2 u to the 1/2. There we go. 2 u to the 1/2 minus, if I have 3/2, it's going to be u to the 5/2. So that means I should have 2/5. And then we're going to evaluate that. I should say plus c, but we're evaluating it from pi over 6 to pi over 3. And we need to change our u's. We're not putting those in, so we're going to say that is going to be 2 times, we said our u was sine x, so it's going to be u equals sine to the 1/2 x minus 2/5 sine to the 5/2 x. And we're going to evaluate that whole thing from pi over 6 to pi over 3. And when you do all of that, you should get an answer. And you should be able to write your answer in decimal form. And when you get your answer, what do you get? You should get 0.239. 0.239. All right, there you go. So here's the last thing I'd like you to do. Evaluate this one right here. Cosine cubed x sine x dx. And I should put this right here. There we go. That makes a little more sense. Evaluate the integral cosine cubed x sine x dx. All right, and when you do this problem, you should get an answer of 1/2 sine x squared minus 1/4 sine to the 4th x plus c. There you go. 1/2 sine x squared minus 1/4 sine to the 4th x plus c. All right, well, stay tuned for some more of these.